During electrolysis of NaCl, students expect that they get Na plus at cathode and Cl minus at anode. But this is not always the same case. Let us know why. So we have two types of electrolysis of NaCl. One is the molten electrolysis of NaCl and the other one is aqueous NaCl, electrolysis of aqueous NaCl. So now, during electrolysis of molten NaCl, we have two ions which are Na plus and Cl minus. During the electrolysis, what happens is Na gets reduced and Na solid is formed at the cathode, and Cl, chlorine, gets oxidized and it gets converted into chlorine gas. So this gas is evolved at anode. So this was electrolysis of molten NaCl. But when aqueous NaCl comes into picture, the number of ions which we have in the aqueous NaCl are Na plus, H plus, OH minus and Cl minus. These are the four ions which compete for the electrolysis. Now at cathode, we have two ions which are Na plus and H plus. So always remember, during electrolysis of aqueous solutions, at cathode, least reactive gets deposited. At cathode, least reactive gets deposited. So between Na plus and H plus, which is least reactive? H plus, right? So H plus gains electrons, that means it gets reduced and hydrogen gas is formed at cathode. Now during the anode, at the anode, we have Cl minus and OH minus as well. At anode, what happens is most reactive gets deposited. Most reactive. Fine. So at anode, most reactive gets deposited. That is the reason chlorine is deposited, because between chlorine and OH minus, which is more reactive? Chlorine is more reactive. So chlorine gets deposited at the anode and chlorine gas is formed because of oxidation. So the products which are obtained during aqueous NaCl, electrolysis of aqueous NaCl, are H2, hydrogen at cathode and Cl2 at anode. Now during electrolysis of molten NaCl, the products are sodium metal at cathode and chlorine gas at anode. So we have to understand this very carefully, that whether the question given, like in the question given, what solution it is, what electrolyte is it? Is it molten electrolyte or is it aqueous electrolyte? Straight away you cannot jump into the answer and say that you get Na plus at cathode and Cl minus at anode. So you need to be very careful and check whether it is molten or it is aqueous. Let us solve few questions which appeared in your past papers. Question 1, which is from October-November 2016. It is saying that solid sodium chloride does not conduct electricity. However, it conducts electricity when molten. Explain why solid sodium chloride does not conduct electricity, whereas molten sodium chloride does. Straight away, the simple answer is, see, ionic compounds in solid state do not have free ions. What are free ions? See, for electricity to conduct, there should be moment of charge. So when you take solid NaCl and pass electricity through it, so you don't have any mobile ions, you don't have mobile charges which can carry electricity from one point to another point. Now, when it comes, when a ionic compound is added to water, when you make aqueous solution, what happens is, when you add NaCl to water, Na gets splitted into, like NaCl gets splitted into Na plus and Cl minus. So here you have free ions, you have mobile ions, which move from one point to another point. They are mobile charges. So what they do is they carry charge from one point to another point. I hope this is clear. So what you can write in exam is, in solid NaCl, ions are held in a fixed lattice and cannot move. When molten, the ionic lattice breaks down into breakdowns into ions which are free to move. Moving ions carry charge, so conduct electricity. So this is how you should write your answer. And when you include this key points, cannot move, fixed lattice, okay, the lattice breakdowns, and then in the molten form they are free to move. Then when you are writing ions carry charge, so conduct electricity. So when you write these points, you get 3 marks for your answer.